Just going to pull our chairs around a little bit. I hope you've got some questions ready. We're going to come to you pretty quickly. Our headlines are Smart Geometry, Constructing for Uncertainty, from the virtual to the actual. Thank you, speakers, for a really wonderful trio of talks that covered a really fascinating array of projects around the subject. I'm sure our two members of the panel who haven't spoken yet might like to jump in early enough. I thought I might just start with the headline from the virtual to the actual, and tap into a little bit some of the images we just saw in the last presentation of from my sort of sensibilities. I just find the formwork so amazing and beautiful and kind of almost tragic to see, it has been regarded as the temporary work and gets discarded, I presume. But what's the journey, in a sense, between the virtual to the actual now? I mean, I'd like to throw that out to each of you in the sense that you might take a polemical position and say that there is, although the capacity now to engage with almost limitless, resources, there is still this sense of erasure in that journey, erasure of the evidence of fabrication. That there's an override that goes with all of that, and fitting in with that, there's this kind of implication in the notes to this group about this territory being about shifting the role of the designer. I think there's also an implication in the conversation in this group that, who is the designer and how many designers are there? There are so many different positions. It's harder now to define who is the designer. But I wonder if this idea could be taken up by any of you about what you think this journey is now from the virtual to the actual. I know, Mark, you talked about the next challenge being about assembly. Is that something you would like to kick off with?
Well, I think so. My perspective is that authorship is now the difficult arena, because clearly there's there is that one person who is responsible for the idea, but the transport of that idea through to the artifact now has the potential involving all sorts of people, each one of whom is indispensable. And somebody I know quite well put the triangle together, where you have typically one person at the top of the triangle who is completely indispensable, and that's the sole author. Then you have the team of anonymous people below it who any one of them can be replaced. And I quite like that model because it implies that leadership is clear. But what I think it means is that line that between the indispensable and the worker bees is actually dropping down. So quite a lot of people are now above that line as being indispensable in the process. And I think the last presentation showed that really clearly. There must have been all sorts of incredible minds going into producing those molds, including the people actually making them.
I think there's an interesting thing to say about the fact that events like this, like Smart Geometry or conference and professionals that we see doing these kind of things, are sort of proving that we are in a state now, or maybe we just feel we are in a state where almost everything is possible. At least we know there are people that can bring the virtual to actual in many different ways, and that we're tackling 3D printing, we're tackling fabrication, we're tackling all these technologies. And what we discuss now is the details, certain aspects of those things, right? But I think there's also a layer to add on top of that on how we see that these things are done by, like, let's say, high-end professionals who are on top of the notch of the design field. But there will be something to say about how these techniques and how this thinking is actually coming to a more democratized population of designers, like the average architect, or like people who are willing to tackle into these things, but they really don't know yet how to do it, or maybe they weren't educated as such. And And I think a really interesting example of that is the fact that the US government very recently, I think last month, they proposed an act that they call the International Fab Lab Act, with which they're trying to pursue the fact that, that there should be fab labs implemented in the US on a ratio of 700,000 people to one fab lab in the next 10 years. And that's something, and they encourage in the bill, in the text of the law, the fact that that is going to yield and it's going to bring further innovation, and it's going to make available for a wider audience of creative people and makers to bring innovation and new ideas into the design field. And so I think that one of the big discussions that we could bring to the table today is also how all of these techniques and all of these new fabrication and new technologies are coming to the wider audience out of maybe these specialized environments where we did discuss these things.
I think I want to pick up on something I think that Mark said, that more people move across that line and participate in a way, which I think is actually a very good thing and actually improves the final outcome. And I believe that has actually to do with, I think you said it as well, democratization of information. In a way, through these technologies, I feel we give the process of building, which is, we give it a kind of nervous system that everybody can refer to. It's like we're capturing information in model speed, like dynamic models, like parametric models, or just information modeling, as we know it, like BIM. But I think that is something that starts to evolve further downstream, and everybody starts to participate in this and starts to work on a digital prototype, which then finds an instance, a physical instance. But I think that's the big shift, and I see it particularly in the UK. It's happening now. The project I worked in was very relying on the fact that we had a very comprehensive digital prototype, and everybody participated in building this virtual building. And I think that is actually what will be driving building in the future, that there will be a digital building that can influence all downstream activities, and everybody can tap into it, get information in it, and build it.
I wanted to pick up on this one as well. I mean, for me, architectural design is never really just that artistic move. There's the shape and then how to build it. It's always trying to manage all the different aspects of building it, function, the design aspects, how it will be constructed, materiality, or to combine all these elements together. So I think it's quite logical that it's not only a top-down, one person does the artistic move and that's it. It cannot be. It was never. And I think now with the new or with the enhanced tools we have, or the more tools we have, it is maybe easier or faster to integrate into very artistic initial expressions all the different aspects of building and materiality.
Yeah, and I meant that authorship has become about leadership rather than owning the idea. So I'm exactly
sure.
Same thing. Yeah.
I mean, if I can add, I think it's also about what the industry accepts and can accept, and we had the conversation about this earlier. What is economic? Maybe 5-10 years ago, we knew we could doubly curve steel and make doubly curved monocoque structures. The projects in which we actually did it are very, very few because it was just too expensive to do. I think now the fabrication industry has also caught up, and doing a monocoque structure is actually possible, also from a financial point of view. It's understanding, I think, through a relationship between the design and the implementation through specialist fabricators is the actual link between those two that allows a project to go ahead. And what we're finding maybe is that while initially there were only sort of specialist designers, now there are also specialist fabricators. I think linking those two aspects of the industry is quite important in order to push the boundaries and do structures which go beyond steel, traditional steel frames.
Yeah, I agree, and I would actually add on to this also the involvement of the workers in the end, because I think whilst we pushed quite the fabrication quite far, what we found on the Aquatic Center a lot of times is that it was enormously important to actually put 3D renderings out there to the construction people on site, because if you put the shuttering together, you have no idea what's supposed to be in there in the end, unless you have it visually next to you on big posters. That's the link where often is missed in the end.
Just maybe one thing, that this doesn't exonerate sort of designers from ignoring all of that and just handing over and handing down, but it actually put us in a situation where we have to be a lot sharper. We have to be able to, I mean, as structural engineers, for example, you know, the way we analyze a monocoque structure or a stress skin is very, very different to the way that we would design a steel frame, you know, and so it's developing also the tools in which we would, you know, we design structures which are 2 millimeter carbon fiber as opposed to, you know, large, you know, beams and columns in steel and concrete.
I think what was quite interesting in all the presentation, that it seemed like really in a kind of extended prototyping, and that's what I kind of also experienced in the workshop and the work we're all doing, that kind of prototyping from kind of digital means into physical means, into fabrication, becomes more and more integrated. And like on the smaller project, there isn't even a kind of divide between prototyping and architectural artifact anymore. I think on the larger projects there is, and I think that's for me the interesting kind of probably innovation, the next step. Allowing, I mean, Mark, you mentioned kind of assembly is still a big thing, and you're saying that you as engineers have to provide a kind of proficiency or more precision in a way to invite fabricators to take that risk, basically, because that's what I think, like in a small project like Mark showed, the risk lies with the people on the floor assembling it and putting in so many man hours, where on a contractor, on a fabricator side, the risk is so much higher. So the question is, how do we actually kind of open up our tool sets, our prototypes, so that we can share the confidence we build up with fabricators? Because they're doing a great job. I mean, on the Aquatic Center, it's amazing that a fabricator moves forward to do all these prototypes without knowing where they're actually going. And it's a great deal of confidence that's been built up there between the parties.
Would anyone like to carry on with that?
I was just going to add, you know, I've never seen an architect show reinforcement drawings before, but I was having a conversation last week with a specialist fabricator about welding. So, you know, it's a lot. I think the discussions we're having with these specialist fabricators are much more sort of detailed. We used to just do drawings and then pass them over. I think now the relationship is much closer, especially on complex projects.
I think that's our experience as well, and I think the tools we have, and like you said, the digital prototypes we have, are now so comprehensive that actually they instill confidence throughout the process. And we're quite used to kind of engage contractors really early on into PCSAs, like pre-construction service agreements, to understand constraints of fabrication, etc., so that these inform the model very early on, or what we're doing, the digital prototype very early on, that there is no, this flow of information doesn't break up when you hand it over to the contractor to do it, but it is actually something that is really informed by how these things are done, like what manual processes are involved, what can be done, where problems are, what kind of robotic machinery is available to kind of design out tolerance, etc. And it just impacts the whole design process, because it opens up all these questions for discussion, because they are all captured in a prototype.
I'm wondering also about opening up thoughts on what sort of new industries or disciplines need to evolve here. You know, if you're Foster's or, you know, AKT or Zaha's, you know, small contractors will respond very quickly, you know, to the opportunity to work with you. But if you're not so well known, you know, that conversation can be quite different. I know when Tom Heatherwick wasn't so famous, you know, they had to make everything themselves in the studio. They had to carry the risk. Huge, enormous, you know, number of projects they made themselves, because, you know, despite how hard they tried to persuade industry to take it on board, they wouldn't take the risk. I'm provoking the next conversation here. Anyone like to pick up on that?
Well, I interviewed Enrique Ruiz-Gelli on this very subject, and his model was that he believes you can take the responsibility as the architect, this is the way you're talking about Thomas Heverwick, and you can take it upon yourself to deliver competent 3D models direct to the fabricators who are delighted, in his opinion, to be speaking with the designer. And you eliminate the whole of this sort of abstraction through shop drawings. And it obviously works for him, and it brings the cost down. The risk is, I don't know how it works in Spain, that you can actually move the risk to the architect from the builder, because I know in Australia that would be almost impossible. But it's obviously a viable route if you can get those structures sorted out.
That's good to hear. Sara?
I think it's still difficult as a brick practice to find a contractor who is willing to take the risk of a very geometric complex buildings or certain elements, because and I think this is the area where what I tried to say before, where there needs to be the most advancement yet has yet to happen is on the actual executing side. The fabrication and the design is working very closely, and we can have this very quick exchange and inform the design process by involving contractors early, but the actual physical execution, the last bit, isn't really integrated yet, because you have this is kind of where the information flow stops, right? Because on site they're still sitting there with a set of plans, and that translation is not smooth yet at all, I think.
Yeah, I mean, we do a lot of work with Thomas, and he has he'd be very different to working with Hadid, because he maybe would be less experienced in sort of doing very large projects as an architect, as a sort of architectural practice, but he's an incredible craftsman. So I think also spanning between different, collaborating with different sort of practices and on different scales. I think it's allows us, at least as sort of engineers, to sort of develop different expertise. With Thomas, we'll understand all about materials and crafted practices and so on. So I think and on the smaller projects, it'd be easier to have a conversation between Thomas and a fabricator, for example. So because he will understand how a piece of metal is welded, but then when you go to a bigger contractor and a bigger project, then you'd have to explain to them how that sort of craftsman is translated to a bigger scale. So I think the ability of jumping from the smaller, more prototypical projects, which maybe border architecture a little bit, to the ones that are more mainstream, if you like, is also very important, I feel, to develop those skills and tools.
Thanks. Well, now it's time I think we should open up questions to the floor. A room full of academics, architects, engineers, practitioners, makers, computational people, and people using robots. And that's, a subject which was to be explored in this panel. I wonder if there's a question from anyone right now who'd like to pick up on that. Is that a question from you, Shane?
This is actually a question for me.
Right.
So we've been watching some of the sessions this morning talking about adaptive architecture, dealing with changing environments on the outside as reactive systems as possible. Now we're kind of on the opposite side, where you guys are doing everything you can to reduce the amount of unknowns, and you get it further and further down the line into actual construction, where in many cases how material is going to behave, how the forces are going to go through, reduce the unknowns as much as possible. I have a question, though, as to where we can get into a middle ground here. And this is actually probably something that would go back to the people who were as part of the first session. At a certain point, you can take it all the way down as minimal as possible, but there's a couple things that will still change. There will still be some materials, some systems that will behave in ways you didn't necessarily predict. There will still be usage scenarios that will change, both from an individual as well as from an entire program of people using the facilities, using the surface, the building, the spaces differently 5 years from now, 10 years from now. Environmental change, all these things are still kind of sitting in a zone that are unknown. And what I'm wondering here is those are things that you're not going to be able to get an answer for. You'll be able to predict within a range, But I'm curious, as kind of an open question, whether you see an opportunity sitting between these zones in some capacity where you reduce the amount of unknowns that you have in terms of fabrication, but then there's augmentation and addition that can be added to this that can enable you to cover this, to be a bit more reactive, to be almost in a way exist in a soft zone where you have some room for maneuvering.
Right, who wants to take that one? Great question.
Well, if I,
Daniel.
I mean, this goes to the heart of what we've been trying to push with our cluster, which is to maybe use some of the expertise in construction and putting things together, in a pragmatic way, developing tools, do something that's adaptable. The first thing that structural engineers try and do is to make things stable and static, and it's a challenge for us and a little bit offsetting sometimes to try and make moving structures. But I think this sort of reacts to a need, I think, for structures to be adaptive to the bit of the building that actually has never been made to move can actually move and adapt to different circumstances, different environments. So I'm hoping that we can do that, obviously, on projects, on real projects, and we'll be pushing these technologies in that direction wherever we can.
Other questions out here?
Alan.
It's a kind of a follow-on, actually. One of those things about architecture is you go into a building and you ask the question about how the heck did they do that? How did you achieve some particular detail or some particular structural feature? And I wonder, sort of going back to Bob's original question, he was mourning almost the loss of the ephemera, the understanding of the constructability. And it's really a question, I guess, for Mark, which is you spent all of that time unpacking what was in Gaudi's mind in order to try to reproduce the bits that he didn't draw. The challenge there, and part of the aesthetic challenge there, is in unpacking what's in his mind from the existing, the remaining material. And wouldn't it have been rather boring if all the working drawings had been there and all the algorithms of production had been written down? Doesn't that rather get rid of the challenge of how on earth did he do that?
I think that was for me. First, just from Bob's point, I always remember have you been to the Goetheanum? It isn't quite to my taste, but photographs of the shuttering that was used to build it certainly is. The answer to the question, Alan, is the fab pod that I showed, I think, is the more important dimension of the work. Yes, of course, if it was just a question of reverse engineering and building the project from a set of competent documentation, I wouldn't be doing it. But it's the fact that there is this interpretation, the fact that that quote I ended up with is exactly the question we're addressing, is what if you're setting yourself a project which is so difficult you can't use conventional techniques to resolve it. And I think that's what turns us on, I think. But I think the essential thing with Gaudi is a quote that one of his assistants made, which was, it was Martinet, he asked Gaudi, he said, look, everything you do is so incredibly complicated, there's a chance that nobody will ever understand what you're up to. And the answer was, well, that's precisely the point. The irony is that if you are trying to build it, then you do need to get behind it. But I think the main point is what you can draw from it and extend in one's own practice and anybody else's.
I can follow on from that too, and it's pure speculation, but some of you will remember some years ago at the Bartlett, two things coincided at the same time. There was an upping of a culture to describe student work more technically in the sort of built kind of terms, and there was a neo-Victorian revival. It was really strange. It kind of happened more or less at the same time. And I've often speculated about it that one aspect of that was it's so easy to go out and read a Victorian building and how it's made. And it's, following on from Alan's point, it's very hard to read a contemporary building and how it's made. And it's why these sorts of conversations are so fascinating, is it's here you get the evidence of the process. But I mean, maybe to provoke it a bit further about this erasure, isn't what also, we're still hanging on to the soother of the drawing somehow? What can be erased in this process is the status of the design as a drawing, as a kind of definitive early representation, and allow a certain set of circumstances to unfold. I think scanning, for instance, is a technology that can allow us to verify decisions as they're made. So, tools are kind of changing the status of media, it seems to me, as well. Here is the role of people. Would anyone like to venture a thought about whether or not we're hanging on to the drawing too much?
I'm going to do my own very quick version. We just use the drawings for pure contractual reasons because that's what the market is used to. What we exchange between designers certainly are models, no longer drawings, really. Even sometimes parametric definitions. And even with contractors, what actually they use to construct their own digital model, fabrication model, is usually a digital model. And the only reason why we still do paper drawings is because that's what the industry is used to and contractually written in. But that's all. I think it's a fairly obsolete system.
I'm very tempted to say no to that. I mean, yes, true, to a degree, but I think drawing for architects is still a quick way of testing exactly what we are supposed to do, which is interfacing all the different elements, the function of the room, how many people fit in there, the table layout, together with the structure, etc. So I think for us, this is the fastest, still the fastest way of doing our job. There is ideas out there, of course, that everything could be done in 3D models, but quite frankly, I have to stop my team permanently from 3D modeling because instead of doing a quick sketch, because it takes far too long still.
Well, what I experienced on the frame is, for example, is more what you said, is that on the building, the Leadenhall building, is that the drawings became purely contractual, and actually there was a vast amount of drawings of 8,000 that we couldn't really have reviewed all of them. It didn't make sense. So instead what we did was an exchange of models. We tested in phases. We had like 48 phases on the mega frame. These came through as final fabrication models, which we tested against our model and then signed off for fabrication. So in a way there was no 2D involved in this process. We signed off 3D information.
I'm very amused by the question because I've, for the last 6 years, my time's been dominated with the project of getting all the 5 main towers down onto the top of the Sagrada Familia with this giant 25-metre high hall with a floating auditorium. And the project started with the first time we ever shared a 3D model. So putting the sketch to one side, which was always the first point of reference, it was only a couple of weeks ago I saw a section, a conventional section. It's a kind of job creation exercise for somebody to just do this drawing. There's no purpose for it, it's after the fact. And I was bowled over when I saw it. It just resonated in a way that only a section can. And I felt deeply embarrassed that for the last 6 years I've been working with the section inside and not actually physically expressed. So I guess it's part of being a fuddy-duddy, but still, very powerful instruments, drawings, not just contractually.
Good. Robert, can someone get a mic to Robert H down here at the front, Shane? Thank you.
Can I just ask a question? You create these drawings just for legal purposes, but you exchange the model. Have you ever been in, or has anybody ever been in a situation where you've been sued, and the only thing you can bring to court are these drawings that you didn't pay much attention to?
Would anyone like to admit to that? Or we have some curtains here you could stand behind.
It's very difficult to be sued on two-dimensional drawings because it doesn't give all the information. And don't believe Sara, because all of their buildings don't have plans or sections which are straight. You know, they have a lot of diagonal sections, but none of them are straight. But you can, how can you get a three-dimensional, full three-dimensional description of your, diving platform? You know, you need a three-dimensional description.
But I think finding someone who's been sued on the basis of 2D drawings, that's probably not the right measure. But I think when it comes to bidding processes, and just to see the spread of bids that come in on a set of drawings, that say something about the quality of the drawings. And if that is within a margin of, 1-2% between the different bidders, then that is a good drawing set. And I think that's something where we probably have to upscale and say what could replace a good drawing set, or what is necessary, and is it feasible for a contractor to kind of scan through 8,000 drawings? That maybe creates a whole risk in itself, just making an offer, making a bid there.
Got another question down here. How much more time have we got? Is there?
Just a few minutes, if this could be
Okay.
last or second last.
Second last question then.
Perhaps following up on this question. When it comes to bidding for a project, as you were describing, I can say perhaps maybe what we've done on IDIS, and maybe perhaps you can tell us what you've done on your project. This was specifically why we have produced that document that I've showed earlier, because then we're asking the contractors to produce their own scope using the principles, and then we check their scope and we see whether or not they followed the principles correctly and they produced the model correctly. And once they've done that, then they will price according to what they have built, and therefore they will not have any excuse later on to say, well, actually, your drawings were not very clear or your rules were not very clear, because they have produced the model that they're going to be pricing for. What have you done in return in order to get around this problem, which many people are facing at the moment?
Just to provide some context, we also tendered the 3D model. It was part of the tender package. I was talking about fabrication drawing earlier.
I'm still hung up on the plan issue versus 3D model. I mean, in the end of the day, what goes on site? How do you bring the 3D model on site? You know, they get the guys who are actually putting maybe digitally fabricated shutter pieces together. They need to follow a plan or something, or an image. This is where it's not because it's an industry standard, but in the end of the day, until everyone is running around with a little iPod where the 3D model is telling them what they have to do, there will be the paper. It has to be, right?
Probably depends on the type of building. So in our case, it's components that they have IKEA kind of manuals of how to put them together. That's how it works. There's no concrete formwork involved.
But this is still a piece of paper.
It's a piece of paper which is generated as a task sheet from a 4D model. They use the model to see what goes where, and then gets handed out when the elements come in, lifted off the lorry. They know how to connect it and which bolts to put in.
So I guess then it's more about the drawing is changing into an instruction.
Into instruction on site, but until then it is model.
Okay, one question, last question down here.
Okay, I just wanted to add to the whole discussion about how you document geometry and so on, and just want to give the example and also the economic factor, like on the Emirates Airlines, also known as the London cable car. There was an issue with double curved structural steel, like 45 millimeter structural steel, which was supposed to be double curved, blah, blah, blah. The original contractor said they couldn't do it double curve, had to do it all out of cone segments, basically, which would end up having kinks in between. So in the end, basically, we found a relationship with a Dutch steel form company, which is used to making hulls of ships, basically. And they use this three-dimensional forming technology to form structural steel, not like cladding, but really 45 or 40 millimeter tapers all the time, of course, steel. And The point is basically, by using that, we were able to reduce the whole assembly line, the whole assembly time and line. We increased the quality, and we actually saved money because it was quicker, less welding was needed, was able to construct the whole tower out of less segments. So I think they're kind of, to some degree, at a point where the whole paradigm kind of shifts, like we kind of increase we kind of embed more and more intelligence and complexity into the part of the assembly that we can control nicely, like can control in the case of the Zaha projects. We can control really nicely. We can control the way the formwork is milled. That's like super precise. We can control how the steelwork is formed. Super precise. We actually exceed the already very tight tolerance levels on the cable car example again. And in this case, the whole process only became feasible by saving money or being cost neutral at least. So I think this kind of, the question becomes redundant at some point. The paradigm changes actually, and it's actually not, yeah, I mean, that's basically the point. You embed more and more intelligence into the object and keep the assembly as simple as possible. And, yeah.
I got the thing, is there a question anyone want to pick out from that? I mean, there's a lot of really rich comments there that I think a lot of people would pick up. I mean, one thing I might say to that is that going back to Usman's conversation in the first panel is like control and, you know, flexibility and, you know, having things really embracing the notion of uncertainty, the notion of you know, multiple outcomes and so on. I suppose I just throw a question back rhetorically, you know, about who's in control. And maybe on that note, it's time to break for some tea and coffees. And before we do, just ask you all to thank our members of the panel here, Mark, Jose, Dirk, Sara, Danielle, and Mikro. Thanks very much indeed.